Okay, number 37. Let me read it for you. It says Jake receives $150 for graduation. So how much did he receive for graduation? 150, right? Okay. So then he buys 3 pairs of jeans, all at the same cost, and then that was over the weekend, and now he has $41 left. So if he only has $41 left, or $41.10, could we figure out how much money he spent? Yeah, we could, right? All we got to do is just subtract. So we're going to take that 41.10 and subtract it from 150. That's how we're going to start this one off. So I'm going to take $150 like this, and then subtract 41.10. Okay. So if I subtract this, does anybody have a calculator and you can punch that out for me? Yeah, go ahead. So what's 150 minus 41? What do you get? 41.10. Excuse me. What is it? Good. Okay, so 108. So we spent 108 bucks on 3 pairs of jeans. So how much money was each pair of jeans? How do we figure out how much each pair of jeans was? Good. We're going to take this amount now and we're going to divide it by 3. So keep that calculator out. I want you to divide this by 3 now. Okay, so if I take 108 and divide it by 3, I'm going to get my answer. 36. Good. 36.30. Okay. So each pair of jeans was $36.30. That's how we figure out that one. Okay. Done. Then number 38, it says 1 package of Skittles cost $1.56. There are 45 Skittles in each package. If this dude Anthony has 675 Skittles, how much did he spend on Skittles? So what we're going to do here is we're going to say, all right, man, if he has this many Skittles, I wonder how many packages that was. So keep your calculators out. What's 675 divided by 45? Because I want to know how many packages of Skittles he has. 15. So 45 goes into 675 15 times. So that means that there's 15 packages in this amount right here. So now what we're going to do is multiply this by $1.56 because each package is $1.56. So multiply this by $1.56 and then tell me what you get in your calculator. 23.4? Okay, so this says 23.4. Did anybody else get that? Okay, so isn't that kind of strange? Can you have 23.4? Oh, wait, no, this is money. Sorry. I was thinking that was the amount of Skittles. Okay, so $23.40. That's how much he spent on Skittles. Okay? All right, next. It says, is this ordered pair, remember this is an x and a y, the intersection point of the equation? So I could tell that these two equations, because they have an x and a y, these are going to be linear. So it's asking wherever that line is and wherever that line is this the intersection point? Is this the ordered pair that works for both of these lines? So all you have to do, just like, you guys remember when we did x and y equals 5 and we came up with a bunch of ordered pairs? Like, what adds up to 5? Yeah, 2 and 3, right? These are all ordered pairs that work. 2 and 3, 4 and 1. You can even do negatives, right? You could do 6 and -1. But see, this doesn't work. 6 and 2. 6 plus 2 does not equal 5. Okay? So we're trying to see if this ordered pair works for both of these. So all we're going to do is just substitute these values in. Okay? So watch as I do this. I'm going to take that first equation, and everywhere I see an x and everywhere I see a y, I'm going to replace it with the 0 and the 3. Okay, so the 0 is the x, so that's 0. And then the 3 is the y, so 3 goes right here. So 3 times 0 is 0, so I just have 12. And then 4 times 3 is 12. So this one checks out. Okay, so this first one, it does work on this one. Now, if it works for this one, then that means that it's the intersection point. Because just because it works for one, that doesn't mean that it's going to work for both. Because this ordered pair right here could be the 0, 3, but see, it doesn't work for that line. It's still on this one. So let's check it on that other one and see if it works. So we have 4, and then this, plus 7, and that's going to be the y equals 2. So for the second one, the 0 goes right here, and then the 3 goes right here. Let's see if this equals 2. 4 times 0 is 0, and then we have 7 times 3, which is 21. So 21 equals 2. That one doesn't work, okay? So since it doesn't work here, that means that it's not the intersection point, so we just say nope. Number 40 says consider the lines. We have 2 lines. What is true about the point 84? Okay, well, let's we could either graph this or we can just substitute this in and see what we get. That's what I would try first. So if I have 4 times the y equals 2 times the x, so 8 goes right here, and then the 4 goes with this one. So 4, that's 16, that equals 16. Okay, so this point definitely works here. So this point 84 is on line M. Now let's try it on the other one. Okay, this one is a, since it's got an X and no Y, that means that this is going to be a vertical line. And let's go ahead and put this value in. So X is just 8. So that's 24 minus 12 is 12, so that one works. So these 2 lines intersect at this point. So that's what's true about this. So this is kind of what this one looks like. This one's like this, and another one's probably going across like this. And so at 8, 4, they intersect. Okay? So we'll say M and N intersect at 8, 4. Okay, number 41. It says apply this transformation from this ordered pair this way. Okay, so notice that the x value, I have to take the x value and I have to multiply it times -5. And then the y value, we just have to add 2 to it. Okay, so I start off with the 3 and I have to multiply it times -5. So -5 times 3, that's going to be my first value, and then I've got to take -2 and add 2 to it. So -2 plus 2, that's what I got to do here. So let's see what we get. -5 times 3, that's -15, and then this times this is 0. That makes sense? Okay, so now we're going to do that for all of them. So -7 times -5, that'll be positive 35. Because a negative times a negative. And then 2 plus 2, that'll be 4. Okay, now let's do this one. 5 times -5, negative 25, good. And then 1 plus 2 would just be 3. Okay, so here it says find 4 points, okay, x, y, that satisfy this equation. So we want to know other ordered pairs that work. So I think what I would do is just graph this, and I know it's in standard form right now, but I'm going to switch it over to slope-intercept form, where the y is by itself, by subtracting 3x from both sides. If I subtract the 3 over to the other side of the equal sign, then I'll have this type of situation. And so right away, I see I've got the y-intercept is right here, so the b term is 4. And so right away I know that that's one of the ordered pairs that'll work, okay? So 0, 4 is going to be my y-intercept. And then I just have to use my slope to find multiple points. So I'm going to draw a coordinate plane. And start at 4. 1, 2, 3, 4. And then just use my slope, which is down 3 over 1. So remember, your slope is always a fraction. So from here I go down 3. Wait, hold on. 1, 2, 3 over 1. There we go. So that ordered pair right there, that's going to be 1, 1. Okay. And then I could also go up 3 and back 1. So watch, I go up 1, 2, 3, and then back 1. That'll be another point. So if this is 4, that's 5, 6, 7, -1. So 7, -1. That's also an ordered pair. And then we could just keep on going down from here. So this one, if I go down 1, 2, 3 over 1, we find out where that point is. So this is down 2. So over 2, down 2. So 2 comma negative 2. There's 4 points. Okay, number 43 says, is the following set of points collinear? Collinear means, are they on the same line? Okay, that's what it's asking. So, let's just graph it and see if they are. So negative 16, negative 7. So negative 16 we'll say is back here. Well, actually, hold on a second. Couldn't we just find the slope between this one and this one, and then see if the slopes are the same between all of them? I mean, that's how you could do it algebraically, if you guys don't want to graph it. But what do you suppose? Do you guys want to graph it or just use the slope formula twice? Just graph it? Okay. That's fine. Alright, so negative 16, that's going to be kind of crazy. Okay, so negative 16, let's do it. 1, 2, 3. Actually, I'm going to put it on graph paper. Can you guys, do you have these down? Keep those somewhere, and I'm gonna switch the slide over to look like this. Oh man, I wonder if I even have 16 right here. Let's move this over a little bit. Okay, so what was the first ordered pair? Okay, negative 16, negative 7. What was the next one? Negative 3, 13? Positive 13? Okay. And then what was the next one after that? Negative 4, negative 4. Oh, negative 24? Okay. So negative 24. I don't even think... Okay, I'd have to go up by 2s. So if I go up by 2, so 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. That's 20... Okay, so here's negative 24, and then down 4 will be 2, 4. All right, so there's the blue point. Now let's do the green point. So negative 3, 13. So 2, here's negative 3 in the middle, and then 13 is going to be 2, 4, 6, 8, 10, 12, 13 right here. Okay? And then the red one is negative 16, 2, 4, 6, 8, 10, 12, 14, 16, negative 7. So 2, 4, 6. All right, we could already tell that this isn't going to work right here. Okay, so these are not collinear. So let's go back and say nope for that one.